Morning, Steven. I am Akansha, and today I am going to present a PPT on partition allocation method, which is assigned by Anjesh sir. So let's see. First slide. So this is my first slide. So in the operating system, the following are four common memory management techniques. So in memory management techniques, we are going to understand what is partition allocation method. So in memory management technique, there are basically four methods. So single continuous allocation, partition allocation, page memory management, segmented memory management. Moving to another slide, the partition allocation method. In partition allocation method, when there is more than one free space available, so we decide that free space from a particular partition allocation method. So it can be a very better method to select that partition if it avoid the internal fragmentation. So as per I have written here that in partition allocation, when there is more than one partition freely available to accommodate a process, it means that when there is more than one partition that is freely available, so we will select that area from a partition allocation method only. So partition must be selected. To choose a particular partition, a partition allocation method is needed. So it is very important that we have to select from a partition allocation method only. Partition allocation method is considered better if it avoids the internal segmentation. When it is time to load a process into a main memory, then and if there is more than one free block of memory of sufficient size, it means that when in a process there is a more than one free space is available, so we will select it. OS decides which free block to allocate. So we select it by a four. There are different placement algorithms. So to select that partition, we used to select from a partition algorithm. There are basically four. So first fit, best fit, worst fit, and next fit. So in next slide you will see about these four. So in the first fit, the partition is allocated, which is the first sufficient block from the top of a main memory. So in a process, when it is in a main memory, so we see it the first fit. It scans memory from the beginning and choose the first available block. So it scans all that process that are going on a main memory, and then it select the first available space which is there. So does it allocate the first hole that is a large enough? So the another one is best fit. Allocate the process to the partition which is the first smallest sufficient partition among the free available partition. It means that if the process is 25 KB, so it will see after that 25, which is the largest number. Like after that in a process there is a 27 KB process is going on, so it will select that 27. Worst fit allocate the process to the partition which is the largest sufficient among the freely available partition. Worst fit means we will see that number which is the largest one. Like if in a process the largest number is 36 and the process number we are taking 25, so the worst fit will be 36, which is the largest one. It is the opposite to the best fit, as we used to see in a best fit just next larger number, and in worst fit the largest number. And it searches the entire list of the whole and holes to find the largest hole and allocate it to the process. The fourth one is next fit. Next fit is similar to the first fit, but it will search for the first sufficient partition from the last allocation point. It is same as like a first fit only, but in next fit we used to see the next number. Like in first fit we are seeing the largest number, and in next fit just next number of that largest number. So we will see in a question. So my question is, I am taking a process number is 16, and you can see here. So you can see that there is the first. So first, as I explained you that first we will see the just next number then a process. So in process there is a number that is 16, and in this we will see that in 8 KB, 12 KB, 22 KB, and 8 KB, which one is the next number then next greater number than 16. So after the 16 there is an 18. So first bit will be 18. In base bits we will. Sorry, in first bit it will be 22 KB, not. In base bit we will see just next number, so that is 18 KB. In post bit, as I explained you that we will see the largest number. So in this the largest number is 36. 36. And in next bit, as I explained you that in next bit we will see the first bit number after that, which is similar to the post bit, that is 36. That's it. Thank you.